Assalamualaikum students. Hope you will be fine. Okay, I'm here with you the second session of your current and electricity difficult questions. Before this, I have recorded few questions for you people. I have solved them. Those questions. Today, I have selected few questions for you, which are considered to be the horrible questions for the students for your incoming paper. In this first question, it is said that a simple circuit is formed by connecting a resistor of resistance R between the terminals of the battery of the electromotive force 9 volt and a constant internal resistance small r. Okay, this is basically a question which is having two unknowns. One is this small r and one is this big capital R, external resistance and internal resistance. Now the further information is a charge of 60 coulomb, this is your Q, flows through a through a resistor, I mean from this capital resistor R in 22 minutes. 2 minutes means you have to convert this into 6 seconds, so it gives you 120 seconds. It dissipates 48 joules of energy. So this is your energy which is dissipated over there. What is the internal resistance small r of the battery? So we are interested in this. We have to calculate this small r. So actually, when we are going to calculate this small r, although it seems very simple, but the informations are very scattered and we have to figure out those informations. Now, according to this question or according to this data, your resistor is having energy dissipation. So I have to find out the current flowing through that resistor. What I have to calculate? I have to calculate the current flowing in that resistor. So when I am calculating the current for current information, I know that current is equals to charge per unit time. So current is 6 divided by 2 times 60. As I earlier calculated, it is 6 divided by 120. So it gives you 0.05 ampere. So this is the current which is flowing through this resistor. Now it's quite easy to understand that if I say that what will be the energy dissipation across this resistor, so I can say that it is equals to power times t. So when I say that it is power times t, so power is equals to your I square r times t. I square r times t. I can directly use that small r, but the problem is I do not have energy dissipation across that. I have energy dissipation across this capital R, this external resistor. That's why I have to figure out this first, then I will proceed next. So the value of energy is 48. um, Here I am going to replace it. This is 48 joule, so current is 0.05 square into R, and time is 120 seconds. So from here, when I calculate this or all for the resistance, I will make this resistance subject, and I will get that this resistance is 48 divided by this all 0.05 square times 120, and I will get this 160 ohm. Okay, this resistance is 160 ohm. Now, as this is one of the part what I calculated, now I'm going to apply the concept of internal resistance. As I know that EMF of that circuit is basically equals to sum of potential differences. So your EMF is equals to I times small r plus I times capital R. So EMF is your 9 volts, so I can take out this I as common. It would become small r plus capital R now. So it's very easy to understand in this way. Your I is 0.05, your small r is unknown, and your capital R is 160, and this would be 9 over here. So after solving this all for small r, I would get 9 divided by 0.05 minus 160. So this will give you 1 20 ohm resistance, and I hope that it is quite easy for you now, because I have used a very easy approach to solve this question, and hopefully this will help you out in your exam, that whenever you are given this type of scattered data, first make that data in a proper way and then solve that. So go through this question again. In this question you are given with energy dissipation and current in this capital R, and you are asked the resistance small r of the battery. So I have used the concept by simultaneous solution to somehow our substitution method. I have calculated capital R by using the concept of energy, that is energy is equals to power times T, and power is equals to I square R into T, and now I got 160 ohm is basically the resistance of that external resistor. And then I use that concept of internal resistance. I have a variable small r, and then I replaced all the values, and I got the answer 20 ohm. Hope this video will help you out for your concept of internal resistance.